Live from New York, it's theCUBE. Covering Big Data New York City 2016. Brought to you by headline sponsors, Cisco, IBM, NVIDIA, and our ecosystem sponsors. Now, here are your hosts, Jeff Frick and George Gilbert.
Hey, welcome back everybody. Jeff Frick here with theCUBE. We are on day 3 of Big Data NYC. We're going wall to wall. We actually came on Monday to cover some of the artificial intelligence, machine learning activities that are now part of Strata and also now Big Data NYC. And we're really excited to be bringing you the coverage like nobody else does, all day long, all the thought leaders. And our next guest we're really excited to have on, Yuanhao Sun, the co-founder and CTO of Transwarp Technology. Welcome.
Thank you, Jeff.
So what are your impressions of the last few days here at the show?
Oh, it's also very crowded as last year. So many people attending Strata conference.
Excellent. And what have you guys been? Have you have any new announcements that you're bringing out here at the show?
No, not this year. But probably we plan to sponsor like Strata conference in New York or San Jose.
Oh, excellent.
This year.
So, Yuanhao, Transwarp, it's not all that familiar to American audiences, but tell us your pedigree in China in terms of some of your large customers and how long you've been in operation, and so that the American audience can understand just how big a force you are in China.
Okay, so Transwarp was founded in 2013, so 3 years ago. So we are a big data company in China. Until now, we have about 500 customers. So they are all deploying Hadoop and Spark. So they are all Spark users actually in China.
Wow.
So we are providing Hadoop distribution to customers in China, but we also build several different products on top of Hadoop. Like the first is a database layer on top of Hadoop. So we provide a SQL engine, and that SQL engine is compatible with Oracle's and DB2's and Teradata's SQL extensions, so that the compatibility level is about 90%, above 90%, so that people can move their like data warehouse workload to our product. And we also have a streaming engine on top of Hadoop, so that streaming engine can support full SQL as well as PL SQL. So this product is used widely in IoT, so people use our product to collect the data from sensors like the wind power generators, so that they can detect the malfunctions of the generators in real time.
Okay, so we'll come back to IoT because that's at top of mind for everyone. But what we found that's interesting here in the States with, and even in Europe, with Hadoop distributions, most of the vendors provide an MPP, massively parallel processing SQL database, as a complementary product. I don't mean free, but as an add-on. But these are all sort of new implementations. They're not compatible with customers' existing investments in Teradata, IBM, or Oracle, and so it's usually they're offloading particular workloads like ETL, or they're doing completely new things like the schema on read. How much effort was it for you to keep that compatibility, and then what does that allow your customers to do when they migrate from the legacy systems?
Yes, actually in the past or at the present, if they are using Apache Hadoop, and they have to use a hybrid architecture. So they combine MPP database together with Hadoop, using Hadoop for ETL and using MPP database for like inductive analysis or some batch processing. But with our product, our goal is to create a one-stop platform so that you do not need to use additional databases. All data is stored in in one single place, and you can run batch processing. You can use our product to do interactive analysis using one single database. So the data is not copied from one database to another.
When you mentioned that with other distributions, typically the customer uses one one part of Hadoop for the extract, transform, load, taking that off the data warehouse, which is, running on a data warehouse, very expensive process. And then they have typically do the analysis in an MPP SQL database. The ETL offloader, is that typically done in Hive, or is it done now more often perhaps in Spark?
So if you are using open source projects, then people usually use Hive for batch processing, for ETL, because it is more stable and scalable. But with our product, our engine is built on top of Spark. So that means all the batch processing is done using Spark engine. Again, because we are compatible with those traditional databases single syntax, that means all the ETL logic can be migrated to our platform without any modification, mostly without modification or with minor modifications. Because we also support distributed transactions, we allow you to insert, update the records on HDFS. That means you can even synchronize the new records or new update from traditional databases to Hadoop in real time. And you can also batch insert or batch update the records on HDFS because we can roll back any failures. And we can also maintain the transaction atomic. So
that's very. You've opened up a gazillion questions that I can ask, but I'm not going to get a chance to on the air, at least right now.
Pick some favorites.
Okay, we'll have to have you back a few dozen more times to actually unpack all that. But let me just ask you, if you built on Spark. The concurrency that you would expect from a data warehouse, Spark doesn't have that sort of workload management built in. How do you compensate for that so that many people can be asking queries at the same time?
Actually, so there are two types of workload. So one is the batch processing kind of workload. That is a traditional data warehouse workload. So it's so you can submit multiple queries, multiple PL/SQL stored procedures, and we actually write a scheduler of Spark so that we can run these stored procedures in parallel. And we also do some we call the inter-SQL optimizations. We can optimize SQLs, optimize all those stored procedures to find like common expressions to emulate data codes, and then we can determine the data dependency between different SQL statements so that we can schedule these SQL statements. So this is basically what a compiler typically do. So
this is what the core of an engine, not the query optimizer, but the other part of a database engine where it says, tell me in what order I'm supposed to do the work so that I can get a lot of work done at the same time.
Yes.
That you've gone and re-implemented that.
Yes, we write a compiler. So that is a distributed compiler for PL/SQL. So we can schedule these SQLs.
And just to be clear, PL/SQL is the Oracle extension to SQL.
Right. We also support DB2's SQL PL. So that's IBM's extension to SQL.
Okay. There's a ton of interest in streaming analysis now, and you had touched on Internet of Things. Tell us what your product set looks like there, and then some of the use cases that customers are using it for now.
Yeah. So our stream product is we are supporting full SQL, full ANSI SQL. That means you can use SQL to create a stream, to connect to Kafka streams, and do any calculation and aggregations. And you can also send alerts using PL/SQL on top of streaming. So in this way, we can simplify the streaming application development significantly. Today, if you are writing a streaming application, you can use only a few lines of SQL statements. In the past, or if you are using Spark Streaming or Storm, you have to develop an application. You have to use like hundreds of lines of codes. But with the SQL, you only need to write a few lines of SQL statements. So this can simplify the development. And then the second features of our stream product is that we are event-driven. So actually, our stream engine is built on top of Spark, but our own version of Spark Core, but it is written in event-driven fashion. So you know Spark Streaming is a mini batch processing framework. That means you have accumulate a few records and process them in a batch. But we are event-driven. We modified the communication mechanism inside the Spark so that the records can be sent to next stage in real time.
That's another few million things I want to unpack. But,
so the
but that's a
Sending
very,
George to China next week.
That's an extremely, I mean, the creator of Spark, Matei Zaharia, who's gone back to academia, that's one of the things he's researching with his students is how to do a sort of a lightweight core in Spark so that you don't have to always do these micro batch elements. So
yeah, we have done that.
Wow.
So the latency can be significantly reduced to like several milliseconds. You know, Spark streaming, the latency typically is 300 milliseconds.
That's so that's phenomenal. Okay, so tell us, who are some of the early customers who are taking advantage of this?
You mean streaming?
Yeah.
Yeah. So like one of our typical customers is that is the wind power generator farm. So you know those generators are usually installed on mountains or on the seaside. But the problem is it's very difficult to maintain these generators. You know, people do not want to go the farm because they're far away from the city.
Right.
So because the equipment is very pricing, so if there is any malfunction, you have to repair it very quickly. So today in China, there are a lot of wind generators installed. They have to build a maintenance system. So we call it intelligent maintenance systems, so that we can collect all the data from the sensors on the generators. So the generators will send the sensor data every second. In one typical customers, they have 10 million sensors. And those sensors will send back the data every second. So that means you have 10 million records per second. And we install Hadoop cluster, actually our streaming cluster, to receive all these events.
And you're looking for signals that would be predicting failure, a potential failure on a windmill?
Yes, there are two use cases. The first is to detect any malfunction in real time, so that you can send alerts very quickly. The second is we actually do some prediction based on the vibration of the generator, so that we can predict which part will be will fail in near future.
And then do you shut it down at that point? Either the generator or the windmill?
Yes. So there is a remote control systems so that you can control the generator remotely. You can shut it down or slow it or turn it off
to minimize the damage.
Yes.
And how much of the system is operating kind of on the mountain with the wind farm, and how much of that is back at a central cloud location, and how do you decide kind of how much data and compute is at each of those locations or points in between?
Yeah, so the distance is usually like 100 kilometers away from the wind farm. So the maintenance system is located in city center, actually. So the latency between the network is usually like several milliseconds. And the data volume is actually huge. So we have a cluster of 100 nodes to receive those sensor data.
And that's in the cloud, or is that
on-premise?
On-premise, locally for the wind farm?
No, so it's remotely
like
in
100 kilometers away.
Oh, 100
and that's where you've got a cluster of compute and store there. Right. And then that connects back. And then is that the same one then that drives back to the control systems
Yes.
as well.
Yes.
And you said it's like what was the latency again?
The latency is like tens of milliseconds.
Okay.
It usually, so the latency is higher, but we only need to send alerts every second. Within 1 second, it will be enough.
To take care of any problems.
Yes.
And how much of the 10 million records per second are you, what type of analysis are you doing near the edge? And then what gets forwarded to the cloud, or does it all get forwarded?
So in this case, we didn't process the data in the edge. So we just send all the data back to the center. But for another customers, they actually install a real-time database called a Pi database in the past.
The Raspberry Pi?
Yes.
Oh, okay.
Yeah. So no. So it's I think it's OSI Pi database. It's a very traditional database.
Oh.
It's a real-time database. So
Okay.
they will store this data in Pi database, and then we will have a receiver to copy the data to data center. So this is deployed in a distributed way. So you have a localized database to store the center data.
I got to ask one quick meta question. Most of the major Hadoop distro vendors here, their customers are struggling to get they've pretty much gotten an ETL project off the ground, and they're just dipping their toes in the business intelligence kind of water. You've got IoT applications with, single-digit millisecond latency running. What's the secret sauce? I mean, besides, of course, your generally brilliant self. How did you guys do this in 3 years?
So actually, it's driven by customers. For those types of use cases, they push us to achieve that. Otherwise, they will not buy our product. So we have to achieve that, and it's the pressure from customers actually. For streaming part, I think it is doable because there is existing streaming frameworks like Flink, like Apex, and Storm. So Storm is event-driven. Flink is also event-driven, but it can allow you to develop batch processing logic on top of streaming events. So we actually borrowed ideas from Flink, but we think it's doable on Spark because we built our products on Spark in past 3 years, and we think it made more sense for us to modify Spark to adopt that programming model. So after several prototypes, we found it is working. So, but another part from Transwarp is the SQL engine. Actually, we spent 3 years to develop the SQL compiler, and it has more than 5 million lines of codes today. So we have to do a lot of work to make it compatible with traditional databases. And because our team members, they have the background in compiler and operating systems. So it's actually easier to write a SQL compiler than to develop a distributed C++ compiler. So we have quite a lot of C++ compiler experts in our company. So it's actually easier for us to develop that SQL compiler.
Wow.
Well, Yuanhao, sounds like you guys are doing all the right things in the right space. Obviously, the IoT angle is huge, and renewable energy is growing super, super fast. So I'm sure we're going to hear more and more about Transwarp without having to go all the way to China. But I think we're going to send George over to spend some time with you and the team. So thank you for taking a few minutes out of your busy day.
Okay, thank you.
Thanks, Yuanhao.
All right, I'm Jeff Frick. You're watching theCUBE. We are live in Manhattan at Big Data NYC. We'll be back with our next segment after this short break. Thanks for watching.